Hey, Simon.
Hello, Nimrod and Nimrod. How are you?
We're good. We're good. Thank you.
Doing well.
Awesome. I'll do a very brief intro and then we can kind of jump straight in. So we have Nimrod Core. Nimrod Core, would you mind putting your hand up? Nimrod on the left is Nimrod Core. Nimrod's a software engineer, and I was loved hearing that you're the #1 contributor to Chekhov, the very popular IAC security tool, which is awesome. Awesome to hear. And we also have Nimrod Hauser. Nimrod, how are you?
Great.
Nimrod Hauser on the right there. Nimrod describes himself as a serial first-time employee in the startup space. I really love that. And Nimrod, you bridge that gap between software development and data engineering as well, right?
Yep.
Awesome. Well, a big welcome to you both. And what I'm going to do is I'm going to put your slides up on screen now. And a big thank you to Baz for also being a kind partner of this conference. And I'll hand over to you both. So enjoy the session.
Thank you for having us, Simon. Welcome, everybody. Today we're going to talk a little bit about building a retrievable code-based memory model. There's lots of big words in there, so let's start taking this apart one by one. So a little bit about us, as Simon said, I'm the co-founder and CTO of Baz. I've been building backend stuff on AWS for more than 10 years. I also do some open source projects. Chekhov and Fantastic. They're awesome. Use them if you need to. They're highly recommended, and I'm not biased at all. Alongside me is another Nimrod. I'm going to call him Hauser. He's our first employee. He's a serial founding employee, as Simon said, and also he really runs the entire field between backend engineering, data science, dashboards, and anything else you might need. He's the guy for it. Let's jump in. So what are we going to talk about? First of all, we're going to talk a little bit about what we do at Baz, because it helps us present the main challenge that we need to break up here, which is the code-based memory. The second thing we'll talk about is how context is king and how it meets software development. And then we'll actually get to the juicy stuff and talk about how we tried, failed, and then succeeded, we think, building a retrievable memory. So let's get started. What is Baz? Baz is an AI-powered code review platform. What that means is we've built a number of agents that do lots of things that help review code, right? So it's a state-of-the-art code reviewing agent. It does PR summaries, which summarizes the changes. It does review comments to identify what the change has done, and maybe it's up to some bad stuff, including custom principles, so trying to identify what works best on your code base. It does code graphs, which analyze the diff in a visual manner to help you understand what changed and what affects what, or what is the chain of events that is going to happen. And of course, we have our own small AI assistant, which will helpfully assist in anything you need to do around pull request and code review. Now, this all sounds amazing, right? We have a state-of-the-art code reviewing agent. It does all these things. What's the problem?
Well, I'm glad you asked, Nimrod. So we built our platform, our reviewer, and everything seemed to be working amazing. It did everything it was supposed to do, and results were good. But as we kind of got a feeling for our own product and we were kind of dogfooding our own stuff, something felt a little bit missing. And took us some time to understand what it was until we thought we finally had it. The main feedback we got and our own feeling was that our reviewer was a bit too robotic. It felt like it kind of lacked an understanding. It understood what was happening, but it kind of didn't understand why, where, how. Is this the best way to do this thing? And I think this, I have an example here that kind of exemplifies this. So this is a PR description that we've generated a while back before we made some upgrades. And we can kind of take a quick look. It says, you change this class, you change a method, the input change, the structure is a little bit different. Everything it says is correct. That really happened. But it's kind of like a dry reiteration, regurgitation of just what happened. There's no, I guess the magic word is context. So that was the thing that was missing. And we thought that's what's required for that, that next step, that X factor. And in these cases, people often say that context is king. Apparently, it is a saying. And this, I have here something that exemplifies this. It's this nice little picture. You see the same symbol twice, but one time you understand that it's a B, and the other time it's a number, it's 13. And the only reason you know this is because of the surrounding stuff, because of the context. Now, this is important, but you might ask yourself, okay, I get it, but how does context actually come into play when you're doing pull requests? What's the connection?
Great question, Hauser. So when we look at the developer mindset when he approaches code review, we split the mindset into 3 parts. The first and most basic part is you need to understand code, right? If you want to review code, obviously, but you also, when you try to step up your review game, you need to understand where this change fits within the system, right? So I have maybe multiple components, multiple apps, multiple services. I changed something. What's going to change for a code review is to understand what will be the user impact, right? I changed this function. It means this service or services will need to be updated. And that means that new functionality will be exposed, old functionality will be removed. What exactly happens? So when we're trying to do this with AI, what we decided to do is approach each of these levels differently. For this most simple level, the diff LLM to give the diff with slightly better formatting. But then when we look at the holistic perspective, you need to add more context, which is beyond the scope of the diff that actually changed. And when we talk about the business impact, we also link to the ticketing service. So it's a Jira, Linear, whatever you're using. And for this talk, or what we saw as the main impact here, it was the flow context. So what is flow context or code-based memory? What we wanted to do is we wanted to create a summary that defines what this piece of code does. In general terms, pretty holistic, what it does in total, because when we use that to review code, to summarize code, to do all the things that I listed before, we'll just do it better because we know what we're working on. So let's say XYZ is a parameter that you created in the PR, but it's also the name of your company. So it's not a typo, it's not a mistake. It makes sense to name that parameter by that name. I have an example here of a flow context. It's a pretty long and boring paragraph, but what you can see if you read a few words there is that it's very specific to what a specific module or a specific part of the code that we have does. It's actually a real part of our code base. It analyzes languages, and we'll talk more about it later.
Okay, so we understand what we want to achieve. We want to, at the end of the day, we're trying to generate this paragraph that gives me a description of what this area of code does. It's worth mentioning that we do have a lot of other prompts in the system because we do a lot of things, and we might have one prompt that we send out to an LLM to summarize the PR, and another prompt in order to actually do the code review. So what we want to do now is want to generate that paragraph that Nimrod just showed so that we can inject that into all the other prompts to make our system better. As a first step, as we start our journey now towards generating this, I can't stress how important this is to do the leanest POC you can. And it means it's going to be manual. We just took our prompts and we ran them and we saw the output, for example, a PR summary. Then we manually wrote the flow context and we added that to our prompt. We ran it again, and we wanted to see if there's a difference. It is kind of exemplified in this meme.
Great show.
Amazing. And you'd be surprised by the number of times that we thought we added context, but the result, the PR summary at the end, was exactly the same. They were the same image. And so this process really, not only did it prove the value, but it also gave us a good understanding of what it is we're trying to achieve. Like, this paragraph should be long, short, technical, high level, hand wavy, full of examples. So that's super, super, super important. Once we understood there's value in it, we were free to actually start automating it. So, okay, so now we understand our task. Our task is to sprinkle context to make the LLM better. But what does that mean? It means that we take whatever is at our disposal, code snippets, diffs, other stuff that we'll talk about, and we have all this data, and we need to find the best way to crunch it in a way that the LLM understands. And at this point, you might ask yourself, well, But why is this?
That's hard.
Why is this hard? I mean, why can't I just take the naive approach, the straightforward one, where I take the entire repository and just feed the entire raw code into the LLM and say, summarize this?
Why not?
Why not? Well, there are a few problems with it. First of all, it's expensive and it is slow. These models are very notorious for being very, very, very slow, and feeding so many tokens in is going to be problematic, and that translates to being just completely unscalable. Moving on. So a lot of research has been done around what we call the lost in the middle problem, or context fatigue. And research shows that the longer the prompt gets, LLMs can start to forget, get confused, ignore part of the instructions, and so forth. You can look at the graph that really shows this clearly. I don't think there are many more efficient ways to make your prompt way too long than just feeding it excessive amounts of code. So might not be the best solution there. Also, context windows. Yes, there are models who support ginormous context windows nowadays, but they're few and far between. Having context windows so large really limits your freedom in choosing models and leaves you kind of only with the slowest ones, most expensive ones, and so forth. So again, big disadvantage. And lastly, code changes, and it changes a lot. And that's where you kind of meet your business requirements, because if you say, product comes and says you need to run this at least once a day, if not at a higher frequency, then that's going to be a problem if the process is really heavy, expensive, and so on and so forth. Okay. At this point, it is worth mentioning, there are some honorable mentions. There are very famous projects that do exactly this thing. They take entire repositories and they just, they summarize them. On the right, we can see Git ingest. On the left, we can see Deep Wiki. And we encourage you to go and check them out. But if you do, you might see that oftentimes the data is a bit stale. It's usually not up to date, and probably because of the reasons we just listed. And so we understood at that point, we'll just have to do it ourselves.
Yep.
Amazing. But before we do, let's do a quick lingo break. We're going to throw some terms around. I just want to focus on two. We will throw the word module a lot, and by that we just mean everything that comes, all the code that's managed by a single kind of package manager, everything under the same package JSON, pip files, Rust crates, Maven, POM files. These are modules or submodules. And the other thing, application flow. Application flow is also a term we throw around. It's an ill-defined, hazy term for everything that just kind of makes sense as a sequence of logical steps in the system. Think anything behind an endpoint, behind a queue, a batch process, everything that just makes sense as an application flow. Okay. I know it's circular. All right. So we can come back to our journey. Our journey is, how do we take an entire module and we squeeze that into an LLM? So first of all, at Buzz, we usually use modules. Why modules? Well, we find it's kind of a sweet spot. It's not as big as repositories. Repositories sometimes have too many things going on, too many responsibilities. Modules are often kind of better structured. If they're structured, if we're not talking about like a poly repo project where a module might equal a repository, but oftentimes it helps. All the monorepo guys will thank us. And we wanted to, going in, we really wanted to leverage batch processing and pre-computation if we could. So our first attempts were trying to use that, and spoiler alert, we kind of went another direction, but we'll talk about that. So we started out trying to summarize entire modules, and toward the end, we took a different path. I'll talk about that going forward. I'll just say, if you're choosing not to summarize entire modules and you're going with individual files, it's important to remember that sometimes documents that are not in a PR are important if you want to understand an application flow. And I have a very small example here. Let's say I have document A that imports document B that imports document C. Document A and C might be part of the PR. If you're trying to understand the application flow, how everything's connected, you're going to want to include document B as well. We'll see that going in. All right, so what did we try? How did we try to squeeze all that data into the LLM? The first approach we tried was leveraging something called TF-IDF. For those people who are not NLP nerds, natural language processing, TF-IDF is a really cool technique. It stands for term frequency and inverse document frequency. In these NLP methodologies, usually you have a bunch of documents, a bunch of text items, and this pool of text documents, they create something called, they compose something called a corpus. And in our example, every module was a corpus. So we had a lot of modules that we kind of processed to analyze together. And in each module, we analyzed each and every word, and we looked for two things, the TF and the IDF. So the TF means we look at each word, and we're trying to see, is it a common word? When I said that we're looking at words in a module, we're usually, in our use case, we're looking at class names, method names. So I can look at the method name like get value or get item, and the TF might be really high. It might appear a lot, and I can say, wow, that's a really common word. It's probably really, really, really interesting. It's really important. But then I look at the other modules out in the wild, I compare it, and I say, oh, it's really popular everywhere. So it's just a common term. And so the uniqueness of it kind of drops. The TF-IDF gives me a TF-IDF score. It's essentially a uniqueness score. So if it's a very common word in the wild, it's less unique. But let's take a look at something from our domain. Let's say I see a method name called analyze diff. And that might be a really common phrase, but it's not as common in other modules. It'll only appear in modules doing, AST stuff and static code analysis. And so that will get a higher TF-IDF score. What we used this technique for was to zero in on the important documents, the unique documents, and the unique methods and classes. And by zeroing in on the proprietary stuff, we thought we'd have a good chance at understanding what the module does.
It's summarizing the important stuff.
Exactly. So we generated something that looks like this, all the important files, all the important methods, kind of ranked by uniqueness. And that's what we actually fed the LLM. We said, hey, here's a module. This is kind of what it does. Here's a list of methods. Can you tell me what it does? And it worked really well. But a reality came knocking, and we realized that not everything is the sexy proprietary stuff. We also have our run-of-the-mill web servers, queue handlers, event handlers, all that kind of common stuff. And when it's less unique, that's where TF-IDF started having murky results. So as we started evaluating that stuff, we realize that we have to go another way. And evaluation, by the way, is an important point. We will get to that. It's a huge part of it.
Did you see this right from the first example, or did you need to look through multiple modules to actually get a feel on this?
That's another amazing question. Thanks. And so when we started out, people sometimes they have their an example that they like, the repo that they usually work on, and they analyze that again and again and again. And running and doing iterations on the same example has its benefits because you kind of get a feeling for it and you get your own gut feeling and a benchmark. But that's also a trap, because sometimes you will get good results on one example, and when we move to other repositories, we start analyzing our front end and our BFF, the backend for front end repo, and that's when things just fell apart. These were the repositories that had the more generic stuff, and suddenly it didn't work. So that's super, super important, and thanks for bringing that up. So next.
Great. So this is a great setup to talk about something else that we've built alongside the module memory, and that's the connection graph. When we look at analyzing modules, specifically a module has a lot of files that interact with each other directly, right? It's not an external import that goes through a different package. So what we do is we scan all the files using TreeSitter. It's an amazing open source that analyzes, I think, 138 different languages to find the different I would say building blocks per language, because some languages have classes and some have structs, some have functions and some have receiver functions go. So we try to grab all the important pieces or blocks. We call them code elements. And then we need to classify them. So we have imports, we have functions, classes, enums, invocations, all of that stuff. And then the last step we try to do is resolve the relationships between them. Why? Because when you change a function, I want to know who uses that function, right? If I'm modifying a call to a function, I want to see what its body looks like. So we try to resolve all of the relationships when we understand what we're reviewing. But this also matches with this module memory. What we thought we would do is, instead of using TF-IDF, let's just grab all of the names of all of the methods and classes in a module, right? We just put them in a list and send them to the LLM. What's the problem? So obviously, that is still too much data. It's very similar to sending the entire code. I mean, it's still less, but it's still a lot, and it explodes. You see here a picture of a connection graph. That's how a connection graph looks on one of our modules. Again, one of our modules. Graphs tend to be really hard to read very fast. And so we understood we have to make this smaller. What we decided to try out was Louvain. Louvain is an algorithm to identify strongly connected components within a graph. So let's say you have a main pie, and it imports a few files, and these files, each one of them is completely separate from the other, and it has a whole module and service and DB and controller and whatever. So each one of those would be a strongly connected component. And what we wanted to do is find the representative, the most important or unique file within each SCC, and take only the elements from that. So take only the class names, the functions from that representative file. And well, it solved the problem of the size, right? It can still be pre-computed. It fixes the TF-IDF in the wild issue. We get actually everything we need. But then we ran into the issue with the thing with summary is, by definition, it drops the less important stuff, right? If I ask to summarize a document, there might be things that just won't make it into the summary. And the problem we faced is we looked at some PRs, and we saw that those PRs change a specific point in this module. It might be the central point, and it might be a secondary point. It might be a new feature that is not within the summary, and then nothing is relevant at all. So what we understood is the problem is different. We don't need to summarize the entire module because it just doesn't work.
Yeah.
So what did we do?
So we understood that the entire module is going to be a problem in some modules that are more kind of cluttered and just have a lot of things going on. And it's interesting because Louvain worked amazingly well from a technical standpoint or a data science standpoint. It did exactly what it was meant to do. It's just that the problem we were asking just wasn't the correct one. Mm-hmm. We understood that we have to be laser focused. We want, at the end of the day, we need to ask ourselves again, what is our goal? And we want to create a summary, not for the sake of creating a module summary, but we want to give context to a specific PR that we're going to analyze. And so what we decided is that we're going to ask the LLM to summarize the module as if the only thing that the module is doing is what the PR is concerned with. For example, our BFF module, like I said, it's super cluttered. It does, it has our AI chatbot, and it does event handling and queue handling and endpoints, web service, and a lot of other things, notification center, and a lot of other things. And we said, okay, let's say I have a PR that deals within the notification center feature. So I'm going to ask the LLM to summarize the module as if the only thing the module is doing is notification center. That way I can make sure that the important stuff make it into the summary. So we understood that we're not gonna analyze the modules like entire modules in their entirety, and each attempt is going to be slightly different, which means we can't really do pre-computation, at least not in the way that we did it before. So we're going to be like custom.
Okay.
And so what we did is that we look in every PR, we look at the documents in the PR. And we said before, when we did the spoiler alert, that sometimes you have documents in the PR, but if you're trying to understand the application flow, sometimes you will have documents that are not in the PR,
right,
that are very heavily connected. And so they're important. So we did a little bit of graph theory magic, and we looked for the best way to find these things. And here in the graph, you can see an example where we have a PR, and the nodes are documents. The red nodes symbolize the documents that are in the PR. The blue nodes are documents that are not in the PR, but they are connected. they're very, very related. And so we included those as well. And that's pretty much how we approach this.
So we leverage the connection graph from before to extend the context?
Exactly. And then those are the files from which we take their content and we send that to the LLM.
I see.
So the wins here are that we're laser focused as before, and when we looked at the results, it made the impact that we were looking for. It's the summaries, the reviews, everything was spot on. So we knew that was it. The problem is that it's not pre-computed in its entirety like we wanted. There is, though, still a retrievable element to it, because creating graphs for the entire module is heavy. That is something we do kind of in a pre-computed manner. We create the horrible import graph that we saw in
the unreadable one.
In your slide, the unreadable
Thank
one.
you.
And what we do on the fly is we just understand which parts of it we need to take and analyze and send to the LLM, kind of that we do on the fly. So it's kind of a really cool hybrid approach.
And then for the files that we selected, what do you send to the LLM? What is the actual payload per file?
So actually, it's very similar to what we did in the TF-IDF. We actually take all the method names and all the class names, and we send that. And we played with it in order to see what works. But that works, and that is certainly enough for the LLM to tell you what the module is doing, which is good news, because we actually discovered that we don't need to send the raw code in its entirety. We can send much fewer tokens, and we still get what we need.
Cool. So it works, right? That's it. We're done.
Not quite, because I still want to take like a minute to just kind of briefly mention evaluation.
Yeah.
This is important. This is a crucial part, an integral part of every data science, ML, AI, whatever name you want to give it, super important. And this problem in particular was interesting because you could say that it's kind of a soft problem. I mean, in our use case, if you want to do something like a PR summary, you're going to have the summary either way, but it can be a good summary or it can be a not so good summary. And it's really about style, wording, that kind of thing. We started out saying that it felt too robotic. How do you measure that?
Yeah.
And so you start by eyeballing it and getting a feeling for it. And that is not being lazy. That is just a way to iterate quickly. But once you start getting into the path and you start automating stuff, it's crucial that you build a framework for benchmarking. And one of the most common ways is using LLM as a judge. I want to mention two cool approaches that you can use to build something like that, even in our soft use case. One, you just ask the LLM if the end result seems good. So you give it the summary in our example, and you give it the flow context, and you ask it, hey, do you think this was generating was the final summary referencing this context? And you just count, you give it a lot of examples, you ask it a lot of times, and just count the number of times it said yes.
Right.
And that's your benchmark. And then you run it every time you make changes to make sure there are no regressions and things of that nature. I think a slightly cooler approach is that you create two summaries, kind of like the meme we showed before from Pam from the office.
With context, without context.
With context and without context, and you ask, which do you think is better? And you count the number of times that the description that was made with context was better. Now, it becomes part of your DNA, of your culture, because you have this benchmark, and the benchmark obviously has a pool of examples that you kind of curate and you kind of collect along the way. And, as we work in our day-to-day thing, people say, oh, that's a nice example. Let's add it to the curated list.
Perfect.
So it's really, really nice, and everybody's kind of in on it.
Two things. One, I think the evaluation is what helped us move stuff into production at a much higher confidence. But I do have one question for you. LLM as a judge, does it matter which LLM?
Ooh, that's cool.
Oh,
so,
no.
Pro tip, just make sure you're using a different model. Don't ask Claude Sonnet to judge Claude Sonnet. It's actually pretty cool, because you're asking Anthropic to judge OpenAI the other way around. Usually that gives you better results because the models can be biased towards their own generated output.
My God, they're like people.
Yes, quite. Last slide. Quick takeaways from our journey. I think we mentioned everything as we went along, but let's just run through them. First of all, don't rush to build. Hands to keyboard is super tempting, but as we showed before, take the necessary time to understand what you want to build, how it needs to look, does it make an impact, do that stuff before running, full steam ahead. Be open to change. We wanted to analyze entire modules. We wanted to do pre-computation. Both things kind of didn't work out, and it's fine. You just need to adapt as you learn more information. Don't fall in love with a single example, as we saw. The number of times I was ready to sign in on something saying this works, and then we tried another repo and things completely fell apart is just too damn high. And evaluate, super, super important. That is your way of knowing that you're still on track, that you still have high quality, that you're not deteriorating. I think these are the main points.
Thank you. Thank you, Nimrod.
Thank you, Nimrod.
Awesome, and thank you very much. That was a really, really interesting session. We have a number of questions in the background that I kind of put in a list as well. So let me quickly remove that from screen so we can see all better. Right, we have a number of questions. Let's see which one we should pick first. Actually, an interesting one, maybe kind of like from the fact that I guess in terms of comparisons with other tools. What would you say, I guess, things like sorcery and the like, and I think there was another one that was mentioned, I think graphite is another one. How would you say it compares? What are the advantages with BAS?
So I would say, first of all, I love the other competitors in this field. And as 2 years ago, I never thought AI would review my code. And now I'm having a hard time living without it. I would say that where BAS differentiates from all the rest is all of the AST work that I kind of hinted at when we talked about solution number 2. So all of the AST stuff and all of the engine that we built out to actually understand the language, find the things that are important, find the links and relationships between them, and then pass that into the LLM. It's kind of you need to move into the space of objects and then back into the space of text to actually have the LLM understand what you're saying, because when we sent out graphs, it just hallucinated. So you really have to turn it into text, and that's kind of the amazing thing, where when you start to talk to it like you talk to other developers in objects and functions and classes and not in lines and text, it understands better. That's what our entire system is built on.
Awesome. We have another couple. First of all, I'll ask, actually, just recently you were talking about the kind of, maybe a little bit about the judging and things like that. Here's a question in and around: can current LLMs reason meaningfully over large modules? So I guess even before we get to that stage, how does the size of the module matter? Because I guess with huge amounts of context, we've seen that degradation across all models before we even get anywhere close to the maximum context windows of models. How does it deal with larger amounts of code bases to look through?
Great question. So models vary, and it varies by module, it varies by vendor. We talked about the lost in the middle problem, and even that problem behaves differently between different vendors. For example, we see that Anthropic models give more attention to things at the end of the prompt. OpenAI models give more attention to things at the beginning of the prompt. So everything kind of works slightly differently. And we mentioned that the modules are sometimes biased towards their own output because it's what they know, it's what they've been trained on, and therefore it seems more familiar. And so there's a lot of trial and error that goes into it to see what works and what doesn't. I will say that there aren't a lot of use cases where we put in a ton of code, because at the end of the day, we're usually not, that's also the whole point of the talk. We're trying not to input the entire code base. We're trying to minimize, to aggregate, to filter. And so that, I think, is one of the things that makes this work.
Yeah. I'll say that when we tried out different stuff, as the context gets longer, the LLM starts just forgetting stuff that you said. So not replying the structure you're asked, or just forgetting some kind of, I love the do not do blah, blah, blah instructions, and it just forgets them and does it anyway. And those are the things that happen when the context gets too large.
Yeah. Okay, awesome. We're about a minute and a half over, but because I'm a terrible host, I'm going to ask one more question. I think it'll be a quick one. So a couple of questions. One from, in fact, similar questions. One, Richard Dock from Discord asks, is there any example code for the TD-IDF approach?
You implemented in like 2 days, so
I think we deleted that code actually, and I think it's called a pet peeve, like where I do a lot of too many things in SQL. The TF-IDF was like a 600-line SQL query that I don't think anybody wants. But I mean, TF-IDF at the end of the day is like it's an equation or a formula, but it's really simple. I mean, it's you can search like TF-IDF in Wikipedia and you can see the calculation. It's super simple. Once you understand like the gist of it, implementation is really straightforward.
Awesome. Cool. Well, a massive thank you to Nimrod for all of your insights and wishing Baz all the best as well. And thank you very much for supporting.
Thank you, Simon.
2 years in a row. So very much appreciate that.
Thank you.
Amazing.
Bye, Simon.